let's continue. We were talking about seaborne distribution plot, right? So we just looked at using this additional attribute to ensure that if a data set has missing values, this would drop those missing values, okay, when you're looking at the plot. And this is basically when I include this parameter, again, not critical, this is essentially going to make sure that it suppresses, the output is suppresses this graph here, okay. So let me run this and see what comes out. So you see it looks slightly different, same data looks different. We don't have any missing values, so this should not have an impact at all, okay. The only difference was this was set to false, so you don't see that graph. The graph also looks slightly different, okay. And of course it's possible to even more fine-tune the attributes, the color and all those different things even more, but again I'm not going to get into it. If you're interested in this, again, I gave you the link. You can go and have a look at the documentation, okay. So let's move on. The next command should be familiar to you. We in the previous module we looked at it. Basic descriptive statistics. So let's look at the descriptive statistics for MEDV. Okay, so I'm going to run this, and you see that it gives you the count, it gives you the mean, standard deviation, minimum, maximum, and the interquartile numbers as well. Okay, and I can have a describe to get various indicators for descriptive statistics, or I can also choose directly. If I only wanted the mean, just type mean. If I want median, type median, close parenthesis, open parenthesis, close parenthesis. So I should be able to do min, max. So all those different things are also available to me if I choose to do it this way. Okay. So what I want to do is I want to try to change this to chess. Okay. So tell me what you see here. When I run this, so the count again unsurprisingly is 506. The mean is 0.06. Standard deviation is this. My question to you is this the right way to get at descriptive statistics for CHAS? Okay. So again, this is more about how comfortable you are with the basic knowledge in stats, right? What are appropriate statistics for categorical variable, numeric variable, and I would argue that if it's a categorical variable, you ought to be looking at different sets of different indicators of descriptive statistics. Okay, so let me again run this run this command. We've already seen this before, to refresh your memory on what Charles River, that variable, looks like. Right? It basically shows that there are lots of zeros, right? About 400 and plus, I think 475 or so, right? And some ones. So two levels, close to Charles River, close to Charles River, not close to Charles River. Two levels, like gender, male, female. Okay. So in this case, I would argue that what you need to do is, again, this is something when you look at the workflow, you probably want to do this up front. Take this Charles River, Charles variable, and make sure that you call this a categorical variable, as type category. Okay, and then if you choose to do this, you can also rename the categories. For example, if 0 and 1, basically call it close and far. Okay, and in this case I think I should actually do far and close. 0 should be far and 1 should be close. Okay, but it's categorical, right? I should know the data so I can type it in. Let me run this, and now I run the same thing. I ran this, I ran the same stats, same command before, right? matplotlib, and I can see, let me run this again. I changed you can see that 0 is far, 1 is close, and you can look at the actual numbers here. So if I run this command again, you're going to see that the categorical labels have changed. It's far and close instead of 0 and 1. The categorical levels, right? Regardless, it's a categorical variable. So now that I have specified Charles as a categorical variable, right? Let's see what this gives me, right? The describe function should now come up with a different set of categorical indicators, right? Count is the same, two unique values, right? The top is for, the most frequent, this is the frequent one, and it occurs 471 times. Okay, so this kind of makes sense for a categorical variable. All right, now let's move on to plotting. Now, this is, so far we've plotted one main variable on the x, and we looked at the frequency distribution, right? How often it occurs, be it a categorical or continuous variable. Now let's try to plot two variables like Charles and MEDV together, right? So let's say, so then now it's going to be a factor plot. So on the x-axis you typically have a categorical variable, and on the y-axis would be a continuous variable, comes from this data set, data frame, right? And I want this to be a bar chart. Okay, and again, this is not critical. All I'm saying here is that suppress something called error bars. Even if you leave it in there, I don't care. But again, if you don't know what an error bar is, do a Google search. Again, I don't want to get too much into the statistical concepts, not central to what we're trying to do right now. We're just trying to draw a bar chart, right? That has on the x-axis Charles River, y-axis median value of the house. Okay, so the x label, plt.x label is proximity of Charles River, plt.y label is median house value. Okay, and I'm going to run this, but before I run this, I want to emphasize again, if you notice, this is plt dot, and think about where this function is coming, or where this is coming from, right? If you go all the way up top here, okay, so this is coming from matplotlib.pyplot. I chose to use the nickname plt for that. So if you don't use this, then you have to use the long form to specify those indicators there. Okay, so let me go down. So here I have the factor plot. I'm going to run this. So you see that you have on the x-axis I have Charles River, and this time I used a better label, proximity to Charles River, right? Maybe I should say proximity to Charles River, far and close. Y-axis is median house value. Okay, of course, if I want, I can choose to have a title as well. I decided not to put it in here. That'll be a third, there'll be a different command for it, like the one we used a few cells before. Okay, so again, to summarize what we've done so far, we've looked at the data frame both in the previous module, in the previous Jupyter notebook, as well as in this Jupyter notebook. We've gone through a whole bunch of features of data frames. Again, if you need to remember one thing from data analysis, including, NumPy, pandas, everything together, you've got to know data frames, most critical. Okay, so here the idea is general workflow is you try to get the data from somewhere. It could be from the CSV file, like the one we're working with right now, Boston Hedge, right? Or you might end up getting it from the web. And again, in the previous Jupyter notebook, I showed you some ways how to get financial data from Yahoo, right? So you got it from someplace. Now you have a data frame. Okay. Now, once you have the data frame with the data, try to get a sense of what the data is all about. Maybe you want to examine the first few rows using this command, right? df head. Take a look at the columns, right? What kind of columns, what kind of variables are these? Is there any way you can get more information about description of the variable? Again, anything that you can try to figure out about the variable, the better it is for you in exploring the data, right? And sometimes, you're dealt a bad hand. All you have is a column name. You don't know what it means. Then you've got to try to work with that limitation. Okay. And once you examine the data, then the main job begins, data cleaning, manipulation. Is there any missing data? How are you going to deal with missing data? Again, there are many different ways of doing it. The simplest way, but not always the most appropriate way, is dropping the rows that has missing values. And that's what that command, that attribute, drop NA, was all about. Okay. Sometimes you can have data from multiple sources, multiple tables. Can you join them together? Again, data frames are really, really good at that. Okay, you can do anything that you can do on a database kind of structure. multiple tables, you should be able to do with data frames. Okay, again, we didn't go into in depth on all of those things, but again, if you choose to do that, have a look at the documentation. Okay, and another important thing that's really critical is what's the level of the variable. Is it a numeric variable? Is it categorical? Right, because you shouldn't be running descriptive statistics on a categorical variable, but you end up getting a mean value for it. It does not really make much sense. So try to get a sense of what kind of variable you think it is. And then remember we had those two functions, two numeric, another one as type categorical. So assign variables to that appropriate level. So you would be basically looking at command somewhere like this. I'm going to go up here. So either this, right, or the one other thing that we did before to numeric somewhere here. I'm going to try to look for this here. There you go. So this and the category, important, and you want to do this not somewhere in the middle, but up front in the beginning. You import all the packages, you get the data frame, examine the data. Once you decide what level it is, try to write all of those things for every column, every row, for every column, every variable, try to group them together. So you know at a glance, where you made the decision and where you wrote the code. In case you made the wrong choice, you need to change it. It's going to be easy to locate and change it. Okay. So again, it's pretty simple. Take an existing column, right? Change it to numeric and override it. Okay, that's it. So I'm going to go down. All right. Where was I? All the way down. We're almost done, I think. Now, so assigning something to numeric, something to categorical, and that's what I'm trying to say here, right? And important to get them done at the beginning before starting data analysis. Okay. Here we don't do this because I just wanted to show you features one by one. So for pedagogical reasons, I didn't do this, but you want to do this for your project. Okay. And again, I mentioned this up front. Pandas is very good for all these things, all the data manipulation, right? But if you want to do visualization, you want either matplotlib or Seaborn. Again, we looked at that. Okay. And if you want to actually run statistical modeling, right, then you need a package like SciPy. Again, SciPy is more general purpose. Statistical modeling would be one subcomponent within SciPy. With SciPy, I believe, has stuff for integration, lots of complex mathematical operations. There's a more general purpose package. Stats model would be one subcomponent. Okay, so you can use that package if you want to run some machine learning models. All right. Another option, of course, which people actually do quite a lot, is you do all your data manipulation in Python because it's such a flexible language, has excellent packages for manipulating data. Then once you've gotten your data ready, then export it out as a CSV file or something like that, and then work with a standard statistical software. It could be open source software like R, it could be SAS Enterprise Miner, SPSS, doesn't matter. Okay, so you can do this in 2 steps. And when you want to do that, again, I'm not going to spend a lot of time talking about it. So if and when you get around to doing your the actual statistical modeling, sometimes, again, not always, sometimes you may need to figure out, is the purpose here to predict something? Let's say in this example, Boston housing, maybe I want to predict median house values, right? So that would be my target variable, and maybe all the other variables are my predictors, right? What do I want to predict? The dependent variable is called a target variable, that is MEDV, and maybe everything else helps me predict the target value. How much is the crime, right? How old is the house? Is it close to the river? Does it have a good view? So those factors could predict the dependent variable, which I call as target variable. Okay, so typically there's one target variable and many predictors, many independent variables. Okay, and so while you do that, you also want to get a sense of descriptive statistics, distributions. Sometimes if it's not normal, maybe you need to make some adjustments, right? And then depending on what you're predicting, sometimes there is nothing to predict. Maybe it's an open-ended what you might call as unsupervised learning models. Again, we're not going to concern ourselves with those. So choose the right model for what you want to do. Run the model, evaluate the model, right? And here's where you'll be using SciPy package like stats model or R or some other appropriate statistical package. Okay, so this is a general workflow, right? So you can just, if you want to, for your project, you should do kind of follow what I have here, and you have all the ingredients in terms of using a data, getting a data, it could be from the web. I can also suggest some CSV files for you, right? Some local files that you can use for your data analysis. I'm going to post them on the course website, okay? And basically get the data and just follow these steps, okay? Do some visualization. Again, make sure that you understand whether it's categorical, numerical, right? And then at the very end, try to run a simple model, right? I haven't shown this to you yet. Again, only if it's possible. Sometimes maybe it doesn't make sense. If it makes sense, then you may want to run a model, simple model, okay? Let me show you what I mean. So here's an example where, so I'm going to eventually run a regression, but before that, I want to show you, let's say that I pick two variables. MEDV is my Y variable. Typically my Y is a target variable, the thing that I want to predict, okay? And on this side, on the X side are the predictors or the independent variables that I'm going to use to predict. And here Boston housing data set had a variable called NOx, right? Nitrogen oxide concentration. It's an indicator of pollution, right? So I want to use this to predict MEDV, okay? Let me make it simple. Number of rooms. Actually, let me make this even easier. Rooms. How do you think a number of rooms in a house predicts housing prices? So small house, a big house. How do you think the price will change, right? So this is my predictor, and this is my dependent variable, target variable, okay? And where is the data coming from? DFB. And I want to fit REG is true. I want to have a line that fits it, okay? And because I said rooms, I'm going to say number of rooms, okay? Again, I'm not running the model yet. I'm doing a regression plot, a scatter plot, okay? Again, if you don't know what a scatter plot is, you're going to see it. It's not critical that you know it. Hopefully you know what it is, right? But I'm just showing you, the important thing is to get a sense of what's going to come up, okay? So let me run this. So it's basically plotting the number of rooms on the x-axis, right? Here's what I want to predict, target variable, median housing value. On the y-axis, it's basically showing you that as the number of rooms increases, or in other words, as the size of the house increases, again, it should be close proxy, right? Number of rooms and size of the house. Your value of the house tends to increase. Again, not too surprising, okay? And here's the other thing that I mentioned. Again, you can ignore this for our class. Lots of numbers clustered around 50, which kind of is a red flag for me, but again, we can ignore this for our class. For me, if I'm analyzing the data, I'm going to be looking at this 50 quite closely, okay? But let us not worry about it, okay? Again, it's a relationship between number of rooms and house price, okay? All right, so I had the label incorrect, so I just changed it right just now. So this is the regression plot that you can quite easily draw using Seaborn, right? Which also uses matplotlib, okay? It's built on top of it. So this is the regression plot. This is a scatter plot, and I want to predict median housing value based on the number of rooms. So the next step, right, is basically, can I use this to run a model? So can I use this to run a linear regression model? That's it, okay? So I'm actually going to be doing this here, right? Before I run the model, I again wanted to show you another interesting thing that you can do with this is, let's say I want to find the correlation between number of rooms and median housing value. And in fact, I want to find the correlation between all of the variables that are there in the data frame. Very simple. All I need to do is this function, data frame dot corr, open bracket, close parenthesis. On this, bingo, I've got the correlation matrix, right? Obviously age would be 1, but it shows you the correlation of age with everything else, correlation of zone with everything else, and so on. Okay, and useful to have. Okay, this is obviously a linear measure, right? Again, I don't want to get into the stats, but something that's useful for you to have. Here's a correlation matrix, and you might notice that between room, right, and MEDV is right here. It's highly correlated, 0.7, high correlation, positive correlation. Okay, so let's move on. Now I want to run this using this idea, regression plot, scatter plot. I want to use number of rooms to predict median housing value, and I want to fit this as a line. So I want to calculate the line. That's what the linear regression is all about. Calculate the properties of a line, right? So I'm going to go down here. So to do that, I need to download a package, right? The package name is statsmodels.api, right? In the old days, it used to be a part of, if I'm right, a part of SciPy, statsmodel. Now they are trying to spin this off because of its importance and make it a separate package, right? So I can actually use import statsmodel.api using a nickname SM. Okay, so here's the code. Pretty simple. SM, right? That's my package reference. OLS is ordinary least squares regression, a kind of regression. Okay, just type. This is the syntax for you. And in bracket, what's my x? That's what's my target variable. What's my dependent variable, right? And fit this to a line. And finally, assign this to a variable. Give me the value. Okay, let me run this. I'm getting an error message simply because I did not run this. So let me run the package, import the package, and now let me run this. And it shows that my MEDV, right here that I specified, is the dependent variable, right? And it gives me a couple of things like R square, adjusted R square. It tells me what the coefficient is. It simply means that 1 unit change, in room would result in 3.6 unit changes in the median pricing value. So if the number of rooms increases by 1, the price should increase by $3,600, right? It's $1,000, $3,600. That's the, even though it says 3.6, the numbers are in thousands of dollars. Okay, so that's what it means. Again, I'm not going to insist that you know what these things mean. Okay, I just want to make sure that you're able to run it right. And this is the starting point for you. If you want to do more advanced models, again, I provided you with a link somewhere here, I believe. If not, just do a search, Google search on stats models, right? SciPy stats models, lots of resources out there that give you more information on this, right? Oh, there it is. So the other thing that I want to mention before I stop is that for the project, I'm going to give you some datasets that you could use. CSV datasets should be fairly simple. So you could use them, do something similar to what I did, and that's the project for you. Okay, but if you want to be more adventurous, I have here some pages that lists literally tens and tens of literally hundreds of datasets. Okay, the trick here is not all datasets might be suitable, so you just need to search to see or pick something that you're interested in. Okay, if not, again, I wouldn't blame you if you just directly decided to use the datasets that I provided. I might probably provide datasets like, I think PIMA, definitely yes. I might give you this, bidder pit, birth weight, right? So you could use one of these datasets and try to replicate, some of the features try to basically follow the process, a gentle workflow in getting some data analysis done. Okay, there will be some data manipulation, but not a whole lot of data preparation. Okay, so again, this is not going to make you an expert in data analysis. It's not, and again, doing the other project, data preparation, it's not going to make you an expert in data preparation, but this is just a starting point for you. I didn't want to do all of those work. I didn't want you to do all of that work in understanding Python. and then not take the next step towards data analysis. Okay, and again, remember that Python is especially strong when it comes to data preparation and data manipulation. Data frames and pandas, very critical. And the other stuff that I talked about, scraping the web. Pretty soon I'll have tutorials on APIs, JSON, right? Interacting with APIs and getting data from the web, or getting data from over the network and processing it. So Python would be very, very helpful in getting you to do that. And I encourage you to try simple projects in data preparation if you can, because it really helps you make the next step. By data preparation, obviously here I mean either the web scraping or some of the other things, like using APIs to grab data and understanding whether it's a dictionary or a list, and processing data. Okay, I haven't posted that video yet, the last video on data preparation. It's going to be on JSON, APIs, and working with APIs, and hopefully they'll be available in a few days. Okay, with that, thank you, and I'll see you soon. Bye.